Hello everyone. In today's class, we are going to solve numerical problems based on half-life period of a first order reaction. In the last class, we derived one expression for half-life period, that is T half it is equal to 0.693 by K. So half-life period T half it is equal to 0.693 by K. This is the expression for half-life period of a first order reaction. So by using this formula, we are going to solve some numerical problems. Let us take first problem or first example. Say I will read out the question once. A first order reaction, it is found to have a rate constant K, it is equal to 5.5 into 10 to the power minus 14 per second. 5.5 into 10 to the power minus 14 per second. Calculate the value of half-life period. We have to calculate the value of half-life period. Let us write the expression first. Say we have half-life period T half, it is equal to 0.693 by K. Since it is for first order, we have to write the formula. T half it is equal to 0.693 divided by K. What is K? K it is rate constant. What is K? Rate constant. Value of K is given. K it is equal to 5.5 into 10 to the power minus 14 per second. So T half it is equal to 0.693 by K. Value of K it is 5.5 into 10 to the power minus 14. 5.5 into 10 to the power minus 14 divided 0.693 divided by 5.5, it is equal to 0.126. Take this 10 to the power minus 14 to the numerator, it becomes 10 to the power plus 14. So unit of K it is per second. So unit of T half or time, it is seconds. So answer, that is 0.126 into 10 to the power 14 seconds. That is the first problem. Next, second one. A first order reaction, it is 50% completed in 80 minutes. Calculate the rate constant of the reaction. Calculate the rate constant of the reaction. So 50% completed means half-life period value is given. Half-life period it is 80. We have to calculate the value of rate constant K. I will write it here. See, we have question number 2. T half it is equal to 0.693 divided by K. T half value is given. 50% completed means half-life period value is given. So T half it is equal to how much? It is equal to 80 minutes. T half it is equal to 80 minutes. We want the value of K, rate constant. So K it is equal to 0.693 divided by T half. This is given value. Given T half equal to 80 minutes. So K it is equal to 0.693 divided by T half, or it is equal to 0.693 by T half. T half means 50% completion. For 50% completion required time, it is 80. So 0.693 divided by 80, it is equal to, it comes out to be 8.66. 8.66 into 10 to the power minus 3. 8.66 into 10 to the power minus 3. T half, T it is in terms of minutes. So unit of K, it is minute inverse. It is what? It is minute inverse. Let us take the third problem. Calculate the half-life period of a first order reaction if the rate constant of the reaction is 6.93 into 10 to the power minus 3 per second. 6.93 into 10 to the power minus 3 per second. Let us write the formula. We have half-life period T half, it is equal to 0.693 0.693 divided by k. 0.693 by k. We have to calculate the value of half-life period. See, given k, rate constant k, it is equal to 6.93 into 10 to the power minus 3 per second. 6.93 into 10 to the power minus 3 per second. So, T half it is equal to 0.693 by 6.93 into 10 to the power minus 3, or 0.693 can be written as what? I will write it like this: 6.93 into 10 to the power minus 1. 6.93 into 10 to the power minus 1. 6.93 cancels out. 10 to the power minus 1 divided by 10 to the power minus 3. It is equal to 10 to the power 2, or it is equal to 100 seconds. It is equal to what? It is equal to 100 second. Unit it is second, because k unit it is in terms of per second. So, unit of time it is second. So, answer T half it is equal to 100 seconds. Last problem. Fourth one, 3/4 of a first order reaction, it is completed in 48 seconds. Calculate the half-life period of the reaction. 3/4 of the reaction it is completed in 48 seconds. We have to calculate the value of T half. Let us write the formula first. We want the value of T half. 3/4. See, 3/4 means it is 0.75, or it is 75%, or it is what? 75%. So, 75% of first order reaction it is complete in what? In 48 seconds. See, by using this value we can calculate the value of k. I will calculate it. So, k it is equal to, we have the formula, k it is equal to 2.303 by t log, it is log r naught by r. 2.303 by t log r naught by r. It is equal to 2.303 by t. What is the value of t? T it is 48 into log 75%, it is completed out of 100. So, initial value is 100. Out of 100, 75% complete means remaining amount it is only 25. It is what? It is 25. 2.303 divided by 48, it is equal to 0.04791. 4791. This is 100 by 25, or it is log 4. Value of log 4 it is 0.6021. 0.6021 multiply, it is equal to 0.0288. 0.0288. Unit of k, time it is in terms of what? In terms of second. So, unit of k it is per second. Unit of k it is what? Per second. So, we got the value of k. Now, we can calculate the value of half-life period. So, T half it is equal to 0.693 by k. We have T half it is equal to 0.693 by k, or it is equal to 0.693 by k. Value of k it is 0.0288. 0.0288 divided on dividing will get 24.06 seconds. Upon dividing will get what? Will get T half it is equal to 24.06 seconds. This is the final answer. Hope it is clear. We completed problems on rate constant K and half-life period. Next topic. Next topic, it is pseudo. What is this? Pseudo first order reaction. Pseudo first order reaction. It is also called pseudo unimolecular reaction. It is what? It is pseudo unimolecular reaction. See, pseudo first order also called as pseudo unimolecular reaction. See, pseudo means false. Pseudo means what? False. That means, see, order of a given chemical reaction, order of what? Order of a given chemical reaction, it can be altered. It can be what? It can be altered by varying the experimental conditions. By what? By varying the experimental condition, that is concentration of the reactant. So, pseudo first order means actual order of the reaction, it is not equal to 1. Pseudo means it is false. Actual order of the reaction, it is not equal to 1. Order of the reaction, it is reduced to 1. By what? By altering or by varying the concentrations of the reactants. Let us write the definition of pseudo first order first. What is pseudo first order reaction? It is a chemical reaction which appears to be of higher order. Chemical reaction which appears to be of higher order, which is made to follow first order, that is first order kinetics, by taking all the reactants in large excess except one reactant. So, what is pseudo first order reaction? It is a chemical reaction which is of higher order. Chemical reaction which appears to be of higher order, and this higher order reaction, higher order means order it is greater than 1. So, higher order reaction, it is made to follow first order, or its order it is reduced to 1 by taking what? By varying the concentration, that is by taking all the reactants present in the reaction that should be taken in large excess except what? Except one reactant. So, what is pseudo first order reaction? Actually, pseudo first order reaction, it is a chemical reaction of higher order. Higher order means order greater than 1. Order greater than 1. So, chemical reaction of higher order, it is made to follow. It is what? It is made to follow first order, or its order it is reduced to 1 by varying the concentration. How to vary the concentration? We have to take all the reactants present in the reaction. All the reactants must be taken in large excess. It should be taken in larger amount except one reactant. That means one reactant must be taken in lesser quantity, whereas remaining all the reactants must be taken in larger quantity. So, suppose if I take the concentration like that, then order of the reaction will be reduced from higher order to first order. Let us take one example. For example, acid hydrolysis. Example for pseudo first order, acid hydrolysis of ethyl acetate. Acid hydrolysis of ethyl acetate. Formula of ethyl acetate, it is CH3COO C2H5. CH3COO C2H5. Hydrolysis means decomposing the molecule by adding water. Hydrolysis, acid means H plus. So acid hydrolysis of ethyl acetate gives ethyl acetate, it is an ester. Ester, it is formed by the reaction of what? It is obtained by the reaction of carboxylic acid with alcohol. Carboxylic acid with alcohol. Same ester, when it is hydrolyzed, it will give what? It will give respective carboxylic acid and alcohol. That is CH3COOH, acetic acid along with C2H5OH. This is ethyl alcohol. So hydrolysis of ethyl acetate gives what? Gives acetic acid and ethyl alcohol. Now in this reaction, two reactants are present. One is ester, other one is water. What is the name of this ester? This ester, it is named as ethyl acetate. So ester and water, these are the two reactants present in the reaction. Now I have to vary the concentration. I will take ester in lesser quantity, whereas water I will take it in larger quantity. Water it is in what? It is present in larger quantity. Ester it is present in lesser quantity. See, when T equal to 0, that is in the beginning, let the concentration of ester, let it be 0.01 mole. Let it be what? Let it be 0.01 mole. Concentration of water, let it be equal to 10 moles. Concentration of ester, it is 0.01. Concentration of water, it is equal to 10 moles. So ester it is in very less quantity, 0.01. Water it is present in larger quantity, that is equal to 10. See, what about the concentration of the product? Initially it is 0. Acetic acid concentration is 0. Alcohol concentration is 0. So after time t or after the completion, see, amount of ester left out, it will be equal to 0. So out of 0.01 moles, whole 0.01 mole will react. It is already present in lesser quantity. So all the quantity that or all the amount which is present in the beginning, it will react. Understood? So out of 0.01 moles, number of moles left out, it is equal to 0. Number of moles left out, it is equal to 0. So reacted ester amount, it is equal to 0.01. See, if reacted amount of ester, if it is equal to 0.01, then water will also react in the same amount. Ester, reacted amount of ester, it is equal to 0.01. Water will also react in the same amount, that is 0.01 only. So out of 10 moles, only 0.01 mole will react. 0.01 mole will react. So out of 10, only 0.01 moles will react, means remaining amount it is equal to 9.99 moles. Hope it is clear. It is nearly equal to 10 only. Nearly equal to what? Nearly equal to 10. So what I told in the beginning, concentration of ester it is very less, it is equal to 0.01. Concentration of water it is very high, that is equal to 10. So after the time interval t or after the completion, amount of ester left out, it is equal to 0. So out of 0.01, whole 0.01 will react. So if reacted amount of ester is 0.01, then reacted amount of water will be the same only, that is 0.01. Out of 10, 0.01 mole will react, remaining amount it is 9.99 or it is nearly 10 only. So after the completion of the reaction, there is no change in the concentration of water. In the beginning, concentration of water it is equal to 10 mole. Even after the completion, its concentration it is nearly 10 only. So there is no change in the concentration of water. There is what? There is a change in the concentration of ester. So rate of this reaction depends only on concentration of ester. Rate of the reaction depends only on concentration of ester, whereas it does not depend upon concentration of water, because water it is there is no change in the concentration of water. So I can write the rate law like this. So rate it is equal to what? It is equal to K into concentration of ester into concentration of water. Since there is no change in the concentration of water, rate it is independent of concentration of water. So its power it is 0. Power it is what? 0. So rate it is equal to K into ester power 1, water power 0. Rate directly depends upon concentration of ester. Rate does not depend upon concentration of water, since there is no change in the concentration of water. So order, what is order? Sum of the powers, that is 1 plus 0, it is equal to 1. It is equal to 1. So it is a pseudo first order reaction. Actually order of this reaction, it is not equal to 1, its order it is reduced to 1 by taking water in larger excess, ester in lesser quantity. One more example we can give. Hydrolysis of sucrose. Acid hydrolysis of sucrose. Formula of sucrose, it is C12H22O11. This is sucrose. Upon hydrolysis, that is upon acid hydrolysis, it produces C6H12O6 plus salt, C6H12O6. This is glucose, this is fructose. So hydrolysis of sucrose produces hydrolysis of cane sugar, I can say hydrolysis of cane sugar, or hydrolysis of sucrose gives glucose and fructose. Here also sucrose, it is taken in very less quantity, whereas water it is taken in larger quantity. So after the completion of the reaction, if you observe the amount left out after the reaction, so concentration of sucrose will change, but there is no change in the concentration of water. Since there is no change in the concentration of water, rate of the reaction depends only on concentration of sucrose. It does not depend upon concentration of water, or rate of the reaction it is independent of concentration of water, whereas rate it is directly proportional to concentration of sucrose. So rate law can be written as rate it is equal to K into concentration of sucrose power 1, concentration of water it is independent, correct, power it is 0. So order it is equal to 1 plus 0, it is equal to 1. So acid hydrolysis of ethyl acetate and acid hydrolysis of sucrose or cane sugar, hydrolysis of cane sugar, both are examples for what? Example for pseudo first order reaction, or it is pseudo unimolecular reaction. Thank you.